Let us see what is current. So electric current is the term of rate of change of charge. It is the time rate of change of charge. In simple words, we can say it as flow of charge. That is Q. So I can be written as dq by dt. So current we have DC and AC. D stands for direct current and A stands for alternating current. So DC current means current remains constant with respect to the time. AC current means it is sinusoidally with respect to current. So for DC is represented by capital I and AC is represented by small I. Next one is voltage. What is voltage? It is also called as potential difference or EMF, electromotive force. So what is voltage? It is the energy required to move a unit charge through an element. If this is a charge, what is the energy needed to move this charge through a conductor is called voltage, right? So voltage pushes the charge in one direction. So we use polarity plus and minus to indicate in which direction the charge is being pushed. Again here DC voltage is represented by capital V and AC voltage is represented by small v. Now let us see the components. Basic components, basic electrical components. So components, we have active components, passive components. Active components, transducers in semiconductor devices comes under the active components. Active component is nothing but it needs to be powered up. In order to work, this active components need to be powered up. We need to give an input voltage like signal to in order to trigger this, right? Passive components, they do not require any external signal or voltage in order to work. It means we can directly connect that resistor, capacitor and inductor comes under this passive components. If we connect directly to the circuit, it will work. It doesn't need any supply voltage or any external signal in order to work. இதை அப்படியே கனெக்ட் பண்ணாலே இது ஒர்க் ஆகும். இதை நம்ம ட்ரிகர் பண்ணுறதுக்கு சம் பல்சஸ் நம்ம கொடுக்க வேண்டியது இருக்கும். So this is the difference between active and passive components. So these resistors, capacitors and inductors plays an important role in the circuits, right? Let's see the basics about resistor. So what is a resistor? So resistor, the primary function of this resistor is to limit the flow of current. So the representation is like this. Right? So you can see the resistors in many circuits. You'll have 3 bands and 1 tolerance band. So I'll show you the color code for this. For remembering, we can see it as BB Roy, Great Britain, very good wife. That is the order. B for brown, black, etc. The color code chart is given. If the colors for a first band are given, third band, the color code is given, and the last one is at the other end we have a tolerance band. That is actually what is tolerance. When a resistor is made, they cannot make it precisely, that is exactly the range correct. இப்போ 0.5 கரெக்டாக 0.5க்கு உங்களால் மேனுஃபேக்சர் பண்ண முடியாது. So they give us what do we call as tolerance. So we can expect the resistor to vary between the certain value, that is this tolerance band, the color code will be silver, gold and no color. If it is silver, the tolerance value is 10%, and for gold, the tolerance value is 5%. If it is no color, the tolerance value is 20%. This 5 and 10% are no longer exist. Nowadays, the resistors are manufactured with 2% tolerance value. That is, if the tolerance value is 5%, we can expect it to vary from plus or minus 5%. Once again, okay, the three bands on the resistor is yellow, violet, brown. Then color code for yellow is 4, then for violet is 7, and for brown it is 0. It is 470 ohms. Okay, like this you have to take the values of the resistor. Next, the relation between voltage, current and resistance is given by Ohm's law. R is equal to V by I. To remember it easily, you can have power triangle. R is equal to V by I. V is equal to I into R. R is equal to V by I and V is equal to I into R. Likewise. So let us take a LED lamp, LED light, right, and a 9 volts battery. The specified maximum current is for this is 30 milliamps. Now, if we connect this battery directly to the LED might burst out instantly. So, we need to connect a resistor in between this in order to limit the current. So, how will you calculate what's the value of resistance? How much ohms should we need to connect in between this? Use this. Voltage is 9 volts divided by, it is 30 milliamps, so 0.03 amps. It is ohms approximately. That's all about resistor. Then coming to capacitors. Capacitors. The symbol for capacitor is like this. It has two plates separated electrically. So it is separated by a dielectric medium, normally a good insulating material. It may be air or anything, an insulating material. It separates the two plates. Capacitor stores the energy in the form of electric field. It produces a potential difference across these two plates. So if a battery is connected between this, it produces positive charges and negative charges. If I stop this ball, what happens? Already the tank is having some amount of water, so the water will flow. The water will not stop instantly. Why? Because the tank is already filled to some amount of water. So the capacitor is like this. This wall, just assume it as a battery, and these are the capacitors, and this is the LED light. So what happens if we connect a switch over here? If I close the switch, LED will glow. What happens if I open it? LED will not glow. But if I connect a capacitor in between this, the capacitor is charged with a polarity like this. Okay. What happens if we open the switch? We close the switch, the LED will glow. What happens if we open the switch? What would happen to this LED? Will it glow? Yes. Why? Why? Because this capacitor is already charged to the battery voltage, so it will discharge. So the LED will continues to glow. So open circuit. Why? Because See, if we connect a battery to a capacitor, so because of this positive terminal, it will get charged plus and minus. Once it gets charged, so the potential across this and this will be same, will remain same. So there is no potential difference across these 2 points. So current will flow only when there is a potential difference across 2 points. The current will flow from higher potential to lower potential. So for DC, the current remains constant. It rises and remains constant. Okay. So when the current is constant, that is when the voltage is constant. So that is the potential difference across these 2 points are same. So there is no current through this circuit. So in other words, we can say the capacitors will block the DC current. It acts as an open circuit. For AC voltage, for AC circuits, what happened? As I told, alternating current varies, alternating voltage varies sinusoidally with respect to time. So you have 2 time periods, T1 and T2. So during this time period T1, your circuit will be like this. Plus minus, plus minus. So current direction of current will be like this. So at T2, what happens? The battery voltage reverses its polarity. The capacitor plates are charged with plus and minus, so it starts attracting the positive charges. Negative terminals start attract the positive charges. So there is a current like this. Okay. So for AC circuits, current will pass straight with little or low resistance. This is for capacitors. Okay. Then let us see about inductors. Inductors. So what is an inductor? When a current is flowing through the current, flux is produced. We know when a conductor is carrying a current, it produces magnetic field, that is flux lines. Magnetic field is nothing but flux lines. So inductor stores the energy in the form of magnetic field. So in order to increase the magnetic field, the wire is coiled up like this. So each turn has its own magnetic field. So the magnetic field increased. Alright. So before that, here, so if the voltage is applied, current will flow. Because of this current, flux will be produced. So there is a rate of change of flux, and EMF is introduced, and the magnitude of this induced EMF is so as the cause oppose the cause producing it. The causes here is V. Inductor will be acting in DC circuits and AC circuits. For DC circuits, inductor acts as a short circuit as the resistance is 0. Why the resistance is 0 in DC? Because for DC the voltage remains constant. So as the voltage is constant, current is constant. Again, there is no rate of change of flux. Then the EMF is 0. So there is no opposition for this to this supply voltage in case of DC. So the resistance, no opposition means resistance is equal to 0. If resistance is 0, it behaves as a short circuit. For high AC circuits, it behaves as high resistance. As the AC is time varying, the voltage keeps on varying its magnitude and also its polarity.